Okay, I'm going to prove that it's 100% open source. Okay, so here's what I do. I go to my website, to the downloads directory. You can do this yourself. Download the ultra small 2 meg distro. I saved it to my downloads directory. Now I go into new machine, new virtual machine, typical. I go to TAD, downloads, ultra small 2 meg, other 64-bit, other 64-bit, 8 gig for the hard disk, doesn't need that, customize hardware, give it 5 gig of RAM, or give it more than 512 meg. 512 meg is the minimum, I give it 5 gig. We get rid of the network card, we don't use networking, we don't use the sound card. We want 8 processors, and we have 5 gig of RAM. It's booting from the CD-ROM. The ISO file is just like a CD-ROM. Install on hard drive, yes. Install inside VMware, yes. Hit a key. Now it's making 2 copies onto the, it's making a copy onto the C drive and onto the D drive. The C partition and the D partition. Reboot, yes. Okay, now this is my bootloader. We're going to boot the C drive. Now we're going to find files starting at root, all binary files. Okay, we're going to, there's kernel, Control Alt Tab, Alt Shift A. Okay, let's Control D. Let's first of all delete the D drive. So let's format the D drive. Format D. Oops. Okay, Control D. So now the D drive has been formatted. We have a C drive. Now let's Control D. We're going to get rid of the kernel.bin, delete. We're going to get rid of compiler.bin, delete. We're going to get rid of bootloader kernel.bin, delete. That leaves us with bootmaster. You know what? I think we can even delete that. I think so. Okay. Let's delete that. And delete old master boot record, delete. So now when we do find files, star.bin, there are no binary files. Now let's do make all. When it compiles the kernel, you have to configure it. This is not how you want to do it. There's if we look at make all, it compiles the kernel and it compiles the compiler and it compiles the kernel. What you need to do is make OS drive boot install. What that does is it calls make all, and then it modifies the boot sector so that it points to the new kernel.bin. Every time you make a new kernel.bin, you have to modify the boot sector because it doesn't search. It's just a hard-coded block address. So if you move kernel.bin, it won't boot. So you have to do make OS, and we make the drive boot. We install the drive boot. The C drive. Okay, enter C. Enter C for the. This is the first letter of the drive is C and D. So C, probe. We do a hardware probe. We have to mount the drive in the kernel. The kernel mounts the drive. So we want 1 for hard drive. Enter, 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 enter. Okay, so we just recompiled the kernel and the compiler. Now if we say find star bin star. Okay, we have we just remade the kernel and the compiler. Now let's say master boot install. It doesn't put the master boot in the gap. You know the gap at block 63 from 1 to 63. It doesn't put it in the gap. It puts it on the file system in that boot directory. So now let's do find file. So now we have it copied the old master boot record. It replaced the boot record, and it created a stage 2 master hard disk boot. Okay, so now we have just proven that it's 100% open source. What we have on the disk, there's the compiler, 18,000 lines of code. There's the kernel, 23,000 lines of code. And the Atom directory is compiled during boot. So we never use object files. We always just-in-time compile. So instead of object files for all these libraries, we use source code. So all these are source code. We don't use object files. We use source code. Okay, it's a very fast compiler. So if I say reboot, we successfully destroyed and rebuilt the entire operating system. I have no networking. We don't have a network card. Now watch this. We're gonna make a distro. We're gonna make let's do something. Let's do something first. Okay, let's go to let's modify the directory command. dir. So this is the directory command. Let's make our own woohoo. Beep. Okay, we're gonna modify the directory command. So here we go. We're gonna say woohoo and beep every time we do a directory. So we're gonna let's start over. Make OS drive boot install. C probe 1 for on my system. The hard disk is number 1. Enter, 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 enter. Okay, and let's reboot. Drive C. It did a directory command. Let's do a directory. Okay, now let's do make distro. We're going to make an ISO file, a 9660 ISO file. So it's 100% open source. I made my own ISO file creator. Okay, so now let's stop this. Let's go to mount virtual disk. Mount disk location. Mount disk. We go to VMware, other 64-bit, the VMDK. And the mount point, we're going to mount it on VM disk. And we're going to do partitions. This is the C and the D drive. We want the C drive. So mount, close. Now we go to my file system. We go to my computer. We go to mount. We go to VM disk. This is a FAT32. So we're going to take my distro, which is a file we just created, copy. Let's put it in the downloads directory. There's the original. So we're going to paste this. Let's see how they compare size-wise. They're the same size. Okay, we made a distro, my distro. Now let's come over here. Let's unmount. Oops, shit. Mount virtual disk. We're going to select this. Unmount, close. So let's remove this from manage, delete from disk. Now we're going to do file system, new virtual machine, typical, browse. Let's go to TAD, downloads, my distro, next. Other 64-bit. Let's call this my distro. My distro installed. $8 gig is fine. Customize the hardware. We don't need a sound card. We don't need network. We want 8 processors, 8 cores. You have to have at least 512 meg of RAM. We're going to kick it up to 5 gig. Finish. So this is a modified kernel that's been made into an ISO file. So install on hard drive, yes. Inside virtual machine, yes. Hit a key. Reboot, yes. Okay, directory. Now let's see what, on this distro there's my flight simulator. This is an 8-core flight simulator. So we can have, you can put graphics in source. Let's go ahead and let's modify the so where is the flight simulator? The flight simulator is miscellaneous. Okay, CD miscellaneous. Factory. There's the flight simulator. So this is the fish. The fish. Shut up, bird. Let's make the fish bigger. We're gonna make the fish bigger. Shut up, bird. We're gonna make the fish bigger, and let's flood fill. Oops. Let's do dither color. What color do we want to make the fish? How about yellow? Dither yellow. Flood fill. Oops. Damn it. Flood fill. Yellow. Dither color. This color. Flood fill. And dither color, red, flood fill. Okay, now let's convert to a bitmap. Transparent. Yes. Okay. Escape. Now we should have big fish in the water that are this color. Uh-oh. Crashed. Let's make even bigger fish. Edit menu. Transform. Let's make monster fish. I bet it's gonna make it too slow. Exit sprite. F5. Let's make the mountains yellow. Let's make the mountains yellow. So let's make the mountains yellow. Control F, green, replace with yellow, replace. Oh, okay, now we're going to run it. Oops. Control F, LT, yellow. Let's change it to brown. Okay, F5. Okay, let's get rid of the fish. Let's make the fish small again. I don't trust that fish. Okay, Control T, Control R. Let's just shrink it. Sprite edit menu. Transform. 0.1. 0.1. Exit. Let's make the blue into red. Control F, blue. Let's change it to red. Remember, this all came from a 2 meg file, and Okay, good enough. I think we've had enough fun for today. Okay, so go to my distro, manage, delete from disk. Yes, delete. Okay, so where can you get graphics in source code? Now you might be wondering what the Z files are. The Z files are compressed, and the compression tool is it's on the distro, not on the 2 meg distro. In the Linux directory on the standard distro, there's TOSC. This is the TOSC is a Linux tool that will uncompress. So anyway, so there, just shut up. I'm the best programmer on earth. I was given divine intellect, and fuck you.